if possible, find the point of intersection between the lines x equals 2 plus t, y equals 5 minus 4t, z equals negative 9 plus 4t, and the line x equals 3, y equals negative 2s, and z equals 3s. So they were nice. They gave it to us in parametric form. So that allows us to skip a conversion step. And then, I've forgotten the first line, 5 minus 4t and negative 9 plus 4t. And I think it was 3, 2s, and negative 3s, but I'm probably wrong. 3, negative 2s, so I got the signs mixed up. That's okay. That's why we check, make sure we've got the right thing. So we set the equations for x equal, the equations for y, and the equations for z equal to each other. And now it's up to us to try and solve for s and t. Okay, so the first one, 2 plus t is 3. Subtract from 3 on both sides, you'll get t should be 1. So now we could take that and put that into one of the other equations. Maybe 5 minus 4t becomes 5 minus 4 is negative 2s. So 5 minus 4, negative 2s, so that's going to be 1 is negative 2s. Divide by negative 2, you'll get negative a half for the value of s. Okay. Now, that doesn't guarantee that we've got a point of intersection, so plug in. T is 1, so plug that into the first line. We get 3, 1, and negative 9 plus 4 is negative 5. So 3, 1, negative 5 is on the first line. Do we get the same thing on the second line? Well, plug in s is negative a half. 3, negative 2 times s, so negative 2 times negative 1 half, which will be 3, 1, and then 3s, 3 times negative a half will be negative 3 halves. So unfortunately, for the s and t values that we worked out, we get different points. So we do not actually have a point of intersection. So no point of intersection. And that's our final answer. But we showed our work, we've explained sort of why it wouldn't work. We solved for a t and an s, and we did a little check, but we did not get the same point on both lines. So no point of intersection there.